Good afternoon, Dr. Manso. Today we will present the real hardware problem, which is casing failure. So, first let me to introduce our group members. We have 6 group members, which is me, Chian Chi, Leong Wei Tong, Wong, Liang, Xuan, Sheng, Foo Lai Suan, and also Kuan Yi. So the agenda for the casing failure for is the topic of our presentation. So let me quote from Winston, which is the success is not the final, failure is not fatal, it is the courage to continue that counts. So the agenda for our presentation is introductions and go through the casing failure characteristic and where to identify and diagnose the casing failure and also mechanism of the tools, and last but not least is our solution to prevent the casing failure. So we go to the introduction of the casing failure. So the longer the production life of a casing, then the casing will easier to getting damaged. So why casing failure is a several thing in production, because it will increase the daily expense and the cost, which is capex of the production. And also the casing failure will threaten our oil productions. So in our presentation, we are going to discuss about the casing failure of its characteristic and also the solution in China, Russia, and also America. So next I will pass to Fu.
So thank you for the presentation by Ryan. So my name is Foo Lai Suan. So I will be presenting about the characteristic and also the type of casing failure. So our presentation will be based on the study case in the China, as mentioned by Ryan just now. So I will be focusing on the China, about the Daqing oil field, Shangri oil field, and also Jilin oil field. So in which based on these 3 oil field, we can see that the casing failure can be classified into different types such as neckling, bending, breaking, and also leaking. So based on the graph as shown in the presentation slides, we can see that there is no uniform percentage of the casing failure, thus indicate that the casing failure are different depends on the well situation due to the uncertainty of the and also the petrophysics. So next, I will be discussing about the characteristic of each of the casing failure. So first will be the necking. So the necking will be the initial condition when the casing failure is being detected. So if it is not treated immediately, it will become more severe, and in the end will result of the fracture of the casing. So the mechanical characteristic of the necking is due to the squeezing effect. So next will be the bending, where the mechanical characteristic of the bending is the axial buckling, where the force is exerted from the top, causing it to bend curve to the sideway. So next will be the breaking of the casing. The mechanical characteristic of the breaking is due to the shearing, where there is the possible presence of fault or slip surface where the force is exerted or the force is exerted on the opposite direction, causing it to be slip and break. So last but not least is the leaking, where the mechanical characteristic of the leaking is the corrosion. So corrosion is due to the acid water used in the mud, and also high temperature and high pressure in the environment, and the critical carbon dioxide act as the catalyst for the chemical reaction involved in the steel casing corrosion and resulting in leaking of the casing. So that's all from me. I will pass the mic to Chan.
Alright, thank you Fu for the presentation. My name is Chan, and now I would like to present the factor that cause the casing to fail. Now let's move on. Okay, so there are 5 main factors that cause the casing pipe to fail. First one is geological. Next one is the casing pipe itself. Afterward is the development. Then the engineering factor. And last but not least is man-made factor. So now let us move on to geological factor. As we all know, the geological formation in constantly moving underground, even though it's very slow and small, but pose a huge threat to our piping underground. So then let us take a look on the south dome. So as you can see here, the south flow will cause the pipe to bend to one side and thus in the end cause the casing to give away. And the picture to the right side, this is a slip surface where the slip moving from two different directions and cause the shearing stress to the pipe and cause the casing to fail. Next, let us look at the corrosion. So the steel of the casing acts with the hydrogen and thus slowly over time the pipe will corrode away. Next, so this is tundra. This is only specific for Russia because due to their cold weather and cold formation, so they have ice underground, and when the ice expand underground, and also this will cause the pipe to fail due to the moving underground, which keeps moving and thus cause the pipe to fail. Next, so this is the casing pipe factors. This is a combination of all five factors: is structural design, steel grade, spool thread, intensity, and drawbacks. So this is more to like the selections of casing pipe stuff. So example, due to lack of the information on the geological formation, so the company or the site will choose the wrong set of equipment casing pipe to use, and thus is the pressure rating and the temperature rating is not suitable for the geological formation, and due to the thermal load and also pressure load and cause the casing pipe to fail. Next, so this is engineering factor. So first is go through the well pattern development. So improper well cutting method will also cause the casing pipe to fail. Next, abnormal high pressure and or we can say over pressure water injection production ratio imbalance will cause the casing pipe to fail as well. Next slide. So sand production. So as you know, the sand produced over time will cause the pipe to fail due to the corrosion. And next, the dog leg, which is the bending of pipe, will also reduce the well integrity. Then the quality of cementing completion is a very huge factor that affect our casing quality. Last but not least is the workover, perforation and fracturing, where this one will apply a lot of pressure and stress on the pipe, which will cause failure in the long run. So next, as you can see, this is the picture where the pipe has been under very huge load and does give away. At the left side, you can see the pipe, the casing pipe breaks. Then the right side is the casing burst due to a abnormally high pressure. Next one. So this is a stress diagram on the casing where this is where this pipe has been under fracturing for a few times and thus cause the pipe to be under heat stress and bending. Next. So last but not least is the man-made factor. So these are very simple. Safety negligence, lack of experience, and worker effectiveness will also cause a lot of problems in the site, not only to the casing failure, but also a lot more problems. So that's all from me. Thank you.
So next, I will talk about the identification on how this paper identify the damaged casing. So next, so there are two ways that this paper show that by using the acoustic array technology and also the visual logging tools, they can easily to identify the casing failure or the damage. So by these two technology, they can figure out the casing failure depth and also the radial location. Next. So these visual logging tools give a real-time well integrity diagnostic by providing the advanced image optimization algorithm. So here is some of the features that make the suggest prevention of these tools, which include the high pressure rating, digital imaging sensor, full coverage, and also large memory use. So therefore, with these visual logging tools, the person can easily visualize the output from the recorded section. So next, okay, so the next technology is the acoustic array technology. This technology is used to identify both the depth of the casing leak and also the radial location in wellbore and provide a clear 2D image of the flow in the downhole. So this 2D image was useful as it can used to avoid the echo of the leak location and it can also detect the real depth of the casing leak. So by conclusion, it can better prevent the non-productive time. So next I will pass it to Ruben.
Okay, thank you, Chin. I'm Leong Wei Tong, and next I'm going to talk about casing failure prevention and controlling. As the saying goes, prevention is better than cure. Therefore, it shall be known that prevention shall take precedence in terms of casing failure prevention and controlling. So there are two main methods of prevention and controlling, which are special technologies for preventing and controlling casing failure and prediction modeling for casing failure. Special technologies for preventing and controlling casing failure include using Maxwell expandable liner system for repairing casing failure, implementing well operability limit model, and well completion methods. Firstly, the Maxwell expandable liner system provides the option of adding a casing string in case hole or open hole environments, either planned or contingency scenarios with minimum loss of wellbore diameter. The Maxwell liner is a bottom-up expansion system which uses hydraulic pressure to pump the expansion cone from the bottom of the liner to the top. It is deployed on a drill pipe inside the casing sizes ranging from 4.5 inches to 13.375 inches and up to 4,000 feet of liner. It can be used as a shoe extension liner, casing patch, casing wear liner, relining valves, corroded casing, and open hole clad due to hole stability issues, water shut off, or lost zones. Next. So well operability limit WOL model can be also implemented as a prevention method for casing failures. Well operability model is used to mitigate well failures due to complex geomechanical loads resulting from compacting in reservoirs. Axial, bending, shear, and collapse loads are transferred onto well tubulars as the reservoir complex. So in order to solve these problems, a well operability limit WOL graph, as shown below for sandstone on the right and shale on the left, needs to be established, and we need to design production strategy or methodology, the safe zone as shown in green. If the operation has to be made in zone 1, the yellow zone, the operation should be as short as possible. Next. So last but not least, several measures can be taken to prevent some of the casing failure problems, such as new cement generation, like elastic cement, to improve the quality of well cementing, use swallowable packer in the shale zone section. Fracture jobs should be done as far as possible from shale and fault to minimize the risk of slippage. Higher grade and thicker casing should be used for the fault section to strengthen the well against collapse. Produce incommingled tubing to maintain bottom hole pressure and reduce the pressure differentials between the bottom hole pressure and the formation pressure surrounding the casing. Other than that, these can also improve the formation stability. Right. Next, I'll pass on to Wong to talk about prediction modeling.
Leong, so I will talk about the prediction modeling for casing failure. First of all, analytical modeling. The GISMA analytical method is firstly proposed that it can predict the displacement above the reservoir based on the polar elasticity, and this method is further improved and such the semi-analytical model is proposed. This model is based on viscoelasticity and 3D nonlinear finite element method that were used to build the geologic model. So this model can predict stress change in overburden and reservoir layer caused by well repair, corrosion, leaking, production, casing collapse pressure, depletion, and etc. So next. The second one is remaining useful life prediction RUI modeling. So it is a combination both statistical method and physics of failure approach. It can run an automatic diagnosis of upcoming production casing integrity problems by combining real-time well condition data from simulation with drilling, completions, and production data. So it can help to extend the well life and optimize the production plan as well. So in conclusion, next slide. The number of casing damaged well in mature oil field has been increased by years, and we found that the conventional technology is not effective to prevent the casing damage. So the strategy of casing damage prevention and control should be focused on prevention rather than control. So that's all from our group. Thank you. Stay safe, stay healthy.